Good morning. Happy Tuesday to everybody that's watching. Thank you so much for joining me this morning. I really, really do appreciate you. Today is Tuesday, May 19th, 2020. And today we are going to be continuing with our discussion and practice on the quadratic formula. Now, as always, hair is in my face. If you missed yesterday's video, which was the introduction of the quadratic formula, go back and watch it. Real simple. Just go back and watch it. So all this week, that's what we're going to be focusing on is the steps of the quadratic formula and making sure that we are confident in building building on what we already know with fundamentals of algebra. And we're just continuing to apply those things and just build onto them. All right. So without further ado, we're just going to go ahead and get started. All right, so we have someone else joining us this morning, so I just want to acknowledge them. Good morning. I thought I heard another ding. Okay, well, either way, if you are joining, good morning, Miss Philomena. How are you?
I'm good. Are you?
I'm well, thank you. We are just getting started with the recording. We are going to continue on with the quadratic formula for today, okay? All right, so let me see. All right, and I know y'all can't see that because I can barely see it. So let me go ahead and, oh, okay, we have another dean that joined us this morning. So as always, let me acknowledge, good morning.
Good morning, everyone.
Good morning, Miss Tiffany. Thank you so much for joining us this morning. So as I call you all, we have the three amigos here today. So we are going to continue on with the quadratic formula, how to apply it, how to work it, how to do it, how to solve it, all of that good stuff. All right. So what I'm going to do now is this. Okay, cool. All right. So I'm going to make this. Whoa. Make that a little bigger there. That way everybody can see it, watching the playback and everything. Whoa. All right. So just want to make sure that everybody can at least see numbers 1, 2, 3, and 4. Because I really want to go ahead and look at numbers 1, 2, 3, and 4 today. So yesterday we talked about when to use the quadratic formula, when not to use the quadratic formula. So in essence, I want us to look at numbers 1 and 2. Now, number 1 says v squared plus 2v minus 8 equals 0. Okay, so remember, all quadratic equations equal 0. We are actually going to see some, such as number 4, that doesn't equal 0, but we'll get there when we get there. Okay, so again, we have v squared plus 2v minus 8 equals 0. Okay, so it says solve each equation with the quadratic formula. Now, as I stated on yesterday, when it comes to trinomials or quadratic equations that do not have a number in front of the first term, or the first term is actually, the coefficient of the first term is 1, you want to follow the FOIL backwards thing that we did last week. And if you do not know what the heck I'm talking about, go look at the playback videos. All right. So in essence, that's really what I want to do. I want to use the FOIL backwards method to where we will have to find the factors of the third term and then take those same numbers and add them to find the sum of the second term. And so that way, I think it will be less work. Now, again, you can use the quadratic formula with this, but, it's, to me, my personal opinion, going backwards and finding the factors and then the sum, I think it would be easier for problems like this. Now, when we get to problem number 3, we are definitely going to use the quadratic formula. That's just no ifs, ands, or buts about Okay, so again, if you have any questions at all, please feel free to chime in. And as soon as I answer those questions, make sure that you put your handsome and pretty little selves back on mute, so that way we can keep down with any background noises. And I want to make sure that people that are watching the playbacks can hear me clearly. Okay, so where is my floating toolbar? Right there. All right, so let me see. Matter of fact, let me go ahead and do this. I'm going to open up another page, and I am going to write down these problems. So that says v squared plus 2v minus 8. All right. Bless you.
Oh, I'm so sorry.
But bless you again.
Thank you.
Ooh, okay. Okay, I see why that's big, because it's zoomed. Okay. So we got, why is that big? So we got v squared plus 2v minus 8 equals 0. Okay. So the good news is we already know how to factor these types of problems. Why? Because we did it last week. The only difference is we're going to add one more step to it. So who remembers what my first step is in trying to factor this trinomial?
The third term.
Yes, you're going to factor the third term. Okay. Uh-oh. So find the factors of the, let me not type all this stuff. Okay, you're going to find the factors of the third term. Okay, so our third term would be negative 8. So I'm going to write all the steps over here because I'm going to need room. Okay, wow. Why is that so big, Lord? Okay. Oh, I know why. Keep forgetting. And my third term in this instance is going to be negative 8. So remember, the number always takes the sign. So you just can't say 8. You have to say negative 8. All right. So here I am going to simply write all of the factors that if I multiply them together will give me negative 8. Okay. So I have 1 times negative 8. Okay. Then I have 2 times negative 4. So I'm going to come over here. Then I have negative 1 times 8. And then I have negative 2 times 4. Okay. So those are all of my factors that if I multiply them together would give me negative 8, no problem. All right, so who remembers what the second rule is?
We add the third term to get the second term.
Yes, ma'am, very good. So you're going to find the sum of the second term by adding the numbers here. So what I'm going to do a little quickie here. Copy. Now my second term in this instance is a positive 2. Okay, so I'm going to put second term is 2. Okay. All right. So now I'm simply going to change these to addition. Because remember, I now have to find the sum. The word sum means to add. So now I have to add these numbers up. Now I know the first two sets is not going to give me 2. So now I'm not even going to mess with those, but I am going to look at the bottom. So I have 2 plus -4. Now, when I add 2 plus -4, that is actually going to give me a -2. That's not what I want. Okay, I don't want that. There we go. Okay, so now I am going to go here and I want a +2 because -2 plus 4 gives me a +2. Okay, so this is what I want. Those are the numbers that I'm going to be using. Okay, so I'm going to bold that. All right. And then my third step would be simply just to factor the first term. Okay, and my first term is simply v squared. Okay. V. So, okay. All right. So when I do that, I am simply going to be left with v times v. Okay. Okay. V times v. All right. All right. So when I do this, I am going to be left with the following. And I'm going to go ahead and write it out so that way you all can see it here. I am going to be left with v minus 2 times v plus 4. So v minus 2 times v plus 4. Now, when we worked last week on the quadratic expressions, this would have been our final answer. That would have been it. We wouldn't have to have, done anything else. However, I'm going to undo that because that line is crooked. But however, because we have it equal to 0, we now have to add in one more step because now we're dealing with an equation. So I want you to follow me here. And when you see this, you're going to be like, oh, okay, Miss Hampton, I got it. You have v minus 2 equal to 0. And you also have v plus 4 equal to 0. The reason why we have this is because we are now dealing with an equation. And remember, in order for us to solve equations, they have to be equal to something. So what I've simply done, all I've done was just take each binomial, the v minus 2, and I set it to 0, equal to 0. And I also took the v plus 4, and I set it equal to 0. Now what you have here is basically one-step equations, and we know how to do one-step equations. So in essence, v is going to be equal to 2, and v is also going to be equal to -4. Now, I know what some of you all may be thinking, Miss Hampton, how in the world did you do that and not use the quadratic formula? Well, remember, because v squared is my first term and my coefficient is 1, it made it easier for me to use, to apply the concept that we worked on last week. And again, I just call it FOIL backwards. It's actually factoring, but I just call it FOIL backwards. So that's the reason why I went ahead and I used the concept that we learned on last week. and I simply just applied it to this. Because again, I do not have a coefficient. My coefficient is 1. So because it's 1, it's easier for me to factor the first term. Okay? So before I continue, I just need to know, how's everyone feeling about this?
Excuse me.
Yes, Miss Philomena.
I'm getting confused because the question say using the in the worksheet, they're using the quadratic formula. Solve each equation with the quadratic formula. And
Okay.
now you are taking us back to the trinomials. So because in my practice, I just went ahead and started solving the equation number 1 with quadratic formula. So how do I explain that? In the exam, do I have to go all this before I solve the quadratic formula?
Okay, that's a very good question, Miss Philomena, and thank you for asking. So again, last week when we talked about factoring trinomials, these were the actual steps of factoring trinomials, okay? So what I'm saying is, I know on the worksheet that I emailed to you all, it says use the quadratic formula. But what I'm telling you, this is very simple. What I'm saying to you is, when it comes to, let me go back to problems so that way. When it comes to problems such as number 1, you can use the quadratic formula, or you can use what we learned last week, which was factoring trinomials. The only difference now is we're just setting everything equal to 0. So we've gone from expressions to equations. Does that make sense?
Yeah.
Okay. Now, I want to skip number 2, and I want us to look at number 3. Now, you're going to see why I say the quadratic formula works better for number 3 versus number 1. Okay, so I want to make sure that we all see the difference and how we can, apply these certain concepts and how we can solve it. Okay, so I'm going to, let me see, where is it? Okay, because I'm going to go to a new page, and what I'm going to do is, okay, let me see if I can do it here. Nope. I was trying to copy and paste, y'all. That's what I was trying to do. Okay, I just have to remember 2v squared minus 5v plus 3. Okay, so I have to remember that. All right, okay, so that was 2v squared. Was that plus 3? See, can't even remember now. Okay, minus 5v plus 3. Okay. Minus 5v plus 3 equals 0. Now, I am going to prove right now, at this very moment, I'm going to prove to you all the reason why the quadratic formula works better with this particular problem versus the factoring. So if I were to follow my rules, right? If I were to follow my rules, find the factor of the third term, right? Okay, so I'm going to follow all these rules. So my factors for the third term would just be 1 times 3. Okay. That's it, right? Those are the only factors that if I multiply them together would give me 3. Now, my second step tells me that I now have to add the term or add the numbers together to get the second term. The problem is 1 plus 3 does not give me a negative 5. So I want you all to catch that connection. And also, because now I have a coefficient other than 1, that means my first terms are going to have to be factored in a different way. Okay? So in essence, this is what I honestly have. I now have to take into consideration this number when I factor out my first term. Okay? So this was the first step. Let me make sure I write that. My second step, I can't do it because, again, I have to take into consideration that I have a number or coefficient in front of my as my first term. So do you see why this would be a headache? Doing the FOIL backwards or the factoring for this particular kind of problem would be a headache. Does everybody see that? And if you don't see
Yes,
it,
ma'am.
okay. All right. So now what I'm going to do is this. Oh man, I shouldn't have did that. Well, okay. Okay. I'm going to retype it, then I'm going to erase it. All right. All right. So I have 2v, okay, 2v squared minus 5v. So now we're going to use the quadratic formula. So that way, again, you're going to see why I said what I said. Plus 3 equals 0. Equals 0. All right. So now I am going to use the quadratic formula, and let me see if I can. I'm going to erase this. Okay. And I'm just going to move this over. Okay. All right. Whoa. All right. Do 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 do. All right. Copy. All right. Do 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 do. Oh, okay. I know y'all probably can't see that, but I will make it bigger. So give me one quick second while I make that bigger for you all, so that way y'all can see it. All right. So. All right. Okay, so again, I have 2v squared minus 5v plus 3 is equal to 0. So now I'm going to ask the question, what number is represented by the first term?
The 3.
No, that's the third term.
Oh, the 2v squared.
Yeah, 2, very good. So it's 2. And then what's my number for the second term, which is b?
5v, negative 5v.
Yep, negative 5. So remember, Mr. McFadden, we're only dealing with numbers. So you necessarily don't need the variable. We don't even care about him.
Okay.
Uh-oh. And now my C, which is the number just by itself, which is the constant, which would be 3. All right, here we go. 3. All right. So these are the numbers that I'm going to be using in my quadratic formula. Remember, with the quadratic formula, it is x. Now remember, let me say this. X is the unknown. So don't confuse yourself with, well, Miss Hampton, they're using a V right here. Why are they using an X? This is just the original equation. So remember, any letter or variable that's used in algebra can represent the unknown. Okay, so I just want to put that out there. All right, so we have X is equal to negative B plus or minus the square root of B squared minus 4AC, and all of that, yes, I said all of that, is over 2A. And again, the quadratic formula is nothing more than a fraction. So again, don't be intimidated by the square root sign. Don't be intimidated by the plus or minus sign. That's elementary at this point. Just know that what you do with fractions is you simplify them. So your goal is to simplify that big old fraction into something small. Okay. So now I'm going to have to write everything out. So I have x is equal to -5. Because remember, b is negative. But because my b is negative here, I'm going to write it in parentheses. Okay. And that's going to be plus or minus the square root of, try to keep that as straight as possible, -5 squared minus 4 times 2 times 3. And then all of that is going to be over 2 times 2. So again, the only thing that I did, I simply just substituted the numbers for the letters. So wherever I saw an A, I put in 2. So I put my 2 where this A is, and I put my 2 where this A is. Wherever I saw the letter B, I just put it in place of the number 5. So that's why I have -5 because B was negative. And I have a -5 here. And wherever I saw the letter C, I just substituted it for the number 3. Okay, so now we have no more letters. We are simply dealing with numbers. And at this point, is really just basic arithmetic. Okay, so 2 negatives give me a what?
A positive.
A positive. So now my -5 has turned into a +5. So again, that's reinforcing integers. Okay, that's going to be plus or minus. What is -5 times -5?
Positive 25.
+25. Very good. Okay, +25. Now I have a -4 times a +2. So what is -4? I can't even see that. -4 times a +2.
A positive. A -8.
-8. And I want you to take that -8 and multiply it by a +3.
-24.
-24. Excellent, Mr. McFadden. You are cooking with gasoline today. And again, all of that is going to be over, what's 2 times 2?
4.
4. And I want you all to pay attention, and I want you to see that even as we are working these problems, you notice how the fraction is getting smaller. So I want you to make sure that you pay attention to that as well, because that's letting you know that you're getting closer to your answer. All right. So now, if I can find my cursor, what is 25 minus 24?
It's a 1.
It's
One.
1. It is 1. Very good. Oh, well, this ought to be easy. What is the square root of 1?
1.
One.
And
1.
no, it's a +1 and a
-1.
-1. Okay, so what I have here is this. I've gotten rid of my square root sign, or the radical sign. That's really what it's called. But either way, I've gotten rid of it. So that's what you want. So I have x is equal to 5 plus 1. And that is over 4. And then I have x is equal to 5 minus 1 over 4. Again, the reason I have two answers is simply because in the quadratic formula, you're going to have two answers. One answer is going to be positive, the other is going to be negative. Oh, I'm sorry, let me rephrase that. When we take the square root of a number, that number is going to be positive, and that number is going to be negative. So I want to make sure that we understand that. Sometimes you may get two positive answers. Sometimes you may get a positive answer and a negative answer. Okay. But when you take the square root of a number, remember that is going to be a positive answer and a negative answer. Okay. So now, again, we are just dealing with basic arithmetic. What is 5 plus 1?
Oh, yeah.
Oh, that's just a nice reminder. Make sure you're on mute because
6.
we're recording. All right, 6. Now, 6 over 4. This is a fraction, and we can reduce this fraction. We really can. So if I reduce 6 over 4, what's my answer? And if you don't know, just say, Miss Hampton, I don't know. Or I forgot.
3 over 2.
Excellent job, Mr. McFadden. So it's 3 over 2. So that means 3 over 2 is one of my answers. Now let me go ahead and get this out the way. When it comes to quadratic formula and you have an answer that's a fraction, if it makes you feel comfortable, you can convert this fraction to a decimal. You can, if it makes you feel comfortable. So in essence, 3 over 2 is the same thing as saying 1.5. Okay. The only time you do not have to convert your fraction to a decimal is when you're dealing with slope. So I don't want you to confuse all of the rules that you've learned this year. Okay. So just keep that in mind. When it comes to slope, keep it in a fraction. Don't do anything extra. Anything else, you can convert your fraction to a decimal. Okay. Just want to put that out there. All right. So now I have 5 minus 1. What's 5 minus 1?
4.
Okay. So what is 4 over 4? What does that equal?
1.
1. So, Ms. Hampton, we did all of this. What does this mean? Well, this basically means that 1.5 and 1 are my final answers in this particular quadratic equation. That's what that means. What it also means is this. I can substitute 1.5 back into wherever I see a V. And when I do that, the goal for me is to get my answer to be 0. Okay, now if you all want me to, I didn't do this yesterday, but I can do it today. I can show you again how to check your answer to make sure that, in fact, these two answers are correct. So if you would like for me to do that, matter of fact, I'm going to do it anyway. I got to do it. It's the only way you're going to see it. All right. So let me do something real quick. All right, I'm going to I'm going to copy this onto a whole nother page. Hey, man. All right. Paste. All right. All right. So my answers were V is equal to 1 and 1.5. And I'm going to use 1.5 instead of 3 over 2 because in most cases, decimals work easier than fractions. Okay. So all I'm going to do is check my answers to make sure that, in fact, these are both correct. So what you're simply going to do is you're going to say 2. And I'm going to start with 1 because that's just easy. 5, 1 plus 3 equals 0. And again, this is basic arithmetic. So I have 1 squared, which is the same thing as saying 1 times 1, and that gives me 1. So 1 times 2 gives me what? 2. Then I have a negative 5 times 1. That gives me a negative 5 plus 3. What is 2 minus 5?
-3.
Negative 3. Wonderful. So if I was negative $3 in my account, but I was blessed to put $3 back in, what's my balance?
0.
So therefore, 1 is a correct answer. So I want to make sure that you all saw what I did to check my work. Now, again, you necessarily don't have to check your work, but I encourage you to do so because, again, when you check your work, you get the opportunity to use to reinforce what we've already gone over. Okay, so I just want to encourage you all to do that. Now I'm going to see if 1.5 is also an answer. Sometimes it can be, sometimes it can't, but I'm going to show you anyway. So again, I am going to say 2 times 1.5 squared minus 5 times 1.5 plus 3 equals to 0. Now, 1.5 squared is the same thing as me saying 1.5 times 1.5. And if I'm not mistaken, isn't it 2.25? I think it's 2. Let me check. So I have 1.5 multiplied by 1.5. Oh, that wasn't a pernt. 5. Okay, I was right. 2.25. Just wanted to make sure. Now, I have 2.25 times 2. Doesn't that give me, hold on. Okay, and I'm going to multiply that by 2. So that gives me 4.5. Okay. Now, I'm going to come over here and say 5 times 1.5. A negative times a positive gives me a negative. So that gives me negative 7.5 plus 3 equal to 0. $4.5 minus 7.5, that gives me a negative 3. Oh, well, look at there. No, we just did it up here, so that verifies that that answer is also correct. Okay. So again, You necessarily do not have to check your answers. If you're satisfied with it and you think it's the right answer, feel free. But my strong suggestion, again, would be for you all to get into the habit of checking your work. That way, if you do come up with a wrong answer, that gives you an opportunity to go back to your steps to see you might have added something wrong. You may have multiplied something wrong. You may have just rushed through it too quickly and might have missed a step. So I just strongly encourage you all to check your work. That's very, very important. Okay. So how do we feel so far about this work? And be honest.
Good.
Good.
Okay, we feel good. Okay.
Just
Uh
the checking part.
just the checking part. Okay.
I ain't got that down pat yet.
Well, that's okay. Because remember, practice makes perfect, and we have nothing but time to perfect what we already have. Okay. Um. So yeah. So Miss Philomena, are you feeling okay? I don't know if she's still with us or not. Okay. Well, hopefully she's still with us, but if not, as always, you all can go back and watch the playback videos and take all the notes you want. All right. Nope. Okay. Let me make this bigger again so that we can see it. Because now I want to look at number 4. Now, can you see number 4? Do I need to make it bigger?
I can see it.
I can
Okay.
see it.
All right. So remember when I said that all quadratic equations must equal 0? Y'all remember that?
Yes, ma'am.
Yeah.
What's the problem with number 4?
It equal 2.
It equals 2.
Yeah.
So that's a problem. That's a serious problem. So now what we're going to have to do is we're going to have to make this problem equal 0. But as always, I can't write on here because I don't have enough space. So I am going to open up a new board. Open up a new board. All right. And what was that problem? All right, let me see. That problem was 2a squared minus a minus 13 equals 2. Okay. So let me see if I can remember that. 2a squared minus a minus 13. Okay. Okay. All right. So I have 2a squared minus a minus 13, and that's equal to 2. All right. So again, all quadratic equations equal 0. This particular one does not. So what you will have to do, you're going to have to reach back to that one-step equation mentality, and you're going to have to make this equal 0. How do we do that? It's very simple. If I have a positive 2 right here, what is the opposite of positive 2?
-2.
Negative 2. So that means I'm going to have to subtract 2 from both sides. Now, the reason why I am putting my negative 2 under this 13, or negative 13 rather, is because they are like terms. So again, all of the reinforcements that we've gone over, you are going to find it in all these problems. Okay, so when I do that, I am going to be left with 2a squared, because remember, can't really do too much with that. So I have 2a squared, and that's going to be minus a. But what is negative 13 minus 2? Negative 13 minus 2. That looks familiar. What does that look like?
Division?
Not division. What sign is that?
Know where to go
Oh,
from.
negative subtraction.
She's lying. I'm fine.
Oh, okay. Who do I have somebody else joining me? Who is that? Yeah, y'all gonna get to see all the little
It's
expressions
me,
today.
Miss Hampton. It's Robert.
Oh, well. Look who decided to join the party. Hey, nephew.
I'm sorry I'm late. I had a situation at home and had to go to the hospital for a situation. I'm sorry I'm late.
Oh, no. That's okay. I'm just happy that you're here. Just make sure that you keep your phone on mute, because we
Yes,
are.
ma'am.
I'm happy you here nonetheless. But
All right.
remember, this is going to be okay. Somebody not on mute. Okay. So just remember, this is subtracting integers. So that means we're going to do our keep, change, or keep, change, opposite, however you learned it, rule. Okay. So we have 13 plus negative 2. And that is going to equal a negative 15. And of course, 2 minus 2 gives us 0. So this is the equation that we are going to use for our quadratic formula. So before we go into the quadratic formula, I just want to reiterate that anytime you have a quadratic equation that's not equal to 0, is equal to something else, you have to make it equal that. And the way you do that is you look at, you're going to perform the opposite operation. So if you have a positive number here, you're going to subtract. If this number was negative, I would have added. Okay, so those are your only choices. You don't need to multiply, you don't need to divide, carry the 5, you ain't got to do none of that. All right, so let me see. Uh-oh. Hey now. No. All right. Shout out to copy and pasting. I don't even have to do anything extra. Just copy and paste. Just go. All right. So I'm going to put this guy somewhere over here. Oh, yeah, I put it over here. All right. So now this is, again, this is the equation that I'm going to be using here. Okay. Or that's the formula I'm going to be using, but this is the equation that I'm going to use. Go ahead and lock this guy. All right. So what number represents A? Two. What number represents B? What's my number for the second term? If you don't know, just say, Miss Hampton, I don't know.
The
Because,
negative
yep, negative what?
15.
Nope, that's C. So I'll go ahead and put that. But what's B? B is negative.
Negative 2?
Well, no, not negative 2. So this is A. This number is represented by C. So what number is represented by B? What's the coefficient for the second
Negative
term?
1.
Negative 1. That's it. There you go. Y'all cooking with gas now. Y'all making me look good. I'm here for it. All right. So remember, when a variable stands alone or when a variable is by itself, the number is always going to be 1. The coefficient is always going to be 1. So I'm just going to put, and I'm going to put a 1 in front of that. Okay. So that way everybody can see it. All right. Now I'm going to go ahead and solve this. By the time I solve all of this, class will be over. See? You get everything within an hour with me. All right. So I have x is equal to negative 1 because b is represented by negative 1 plus or minus, keep that straight. All right. The square root of b squared, which is negative 1, minus 4 times 2 times negative 15. Again, do not be intimidated by this big number. Okay, you don't want them kind of problems. You ain't got to even do all that. All right, and all of that is over 2 times 2. Okay. Now, I'm just going to run through this so that way, so stay with me. If you got a question between the explanations, just jump right on in. Remember, 2 negatives give me a positive. So therefore, this negative 1 is essentially going to turn into 1. Okay. And that's going to be plus or minus. Negative 1 squared is the same thing as saying negative 1 times negative 1, which gives me a positive 1. All these ones going on. What's happening with the ones? All right. Now, this is the kicker. You have negative 4 times a negative 15. A negative times a negative gives you a positive. So my answer is positive 60. And I'm going to take positive 60 and multiply it by 2. Because remember, all of this is multiplication. Okay. So 60 times 2 gives me a positive 120.
Miss Hampton, why didn't you multiply 4 times 2 first?
Oh, it because multiplication is what's the word I'm looking for? An associative property. It doesn't matter where I start. I could have said negative 4 times 2. I'm sorry, negative 4. Yeah, negative 4 times 2. And that would have given me a negative 8. Negative 8 times negative 15 is still going to give me 120.
Oh, okay.
But the reason why I did that was because I knew that a negative times a negative gave me a positive.
Oh, okay. I mean,
So,
because I saw you do it. I saw you do it that way before, and I ain't understand why you switched it up this time. So I understand now.
okay, no, and that's not a problem. Remember, when I can transpose numbers in multiplication, and I'll still come out with the same answer. So again, like 3 times 7 is the same thing as 7 times 3. So I can move the numbers any way I want to, but the answer will still come out to be 21. That makes
Yeah,
sense?
yeah, makes a lot of sense.
That's all I'm trying to do, people. I'm trying to make it make sense. That's it. That's all I'm trying to do. And then, of course, we got the 2 times 2 equals the 4. Now, what is 1 plus 120?
121.
120. Oh, here you go. Here it is. This is it right here. What is the square root of 121? And if you say, Ms. Hampton, I have no idea, you can tell me that. It's all right.
11?
It is 11. It's a positive 11 and a negative 11. Can't forget about him. We always forget about him, but we can't forget about him. And I'm running out of room here. So I'm going to put over here that it's a plus or a minus or a positive and a negative 11. All right. So I have x equals 1 minus 11 over 4. All right. What's 1 plus 11?
12.
12,
What's 12 divided by 4?
3.
3. So x, and I'm going to put it over here because I'm running out of space. X is equal to 3 for this particular one.
We still trying to get to 0, right?
No, we passed that. We getting to the answer.
No,
Yeah, we,
I'm talking
huh?
about 'cause when we started the problem, it was a 2, right?
Yeah. So follow my cursor, Mr. McFadden. Because this was a 2, we had to subtract 2 for both sides. So you see where I'm at?
Oh yeah, okay, I got you.
So that's the reason why we are now using this particular problem right here
Oh,
instead of this one.
got you.
Because I'm going to tell you now, I'm going to say this and then we're going to be done with it. A lot of people, because I've seen this, would have said A is equal to 2, B is equal to -1, and C is equal to -13. Then they would have did all of the quadratic formula, got a crazy answer, and then looked at me like I owed them child support. Okay? And remember, I've been doing this a long time. So remember, anytime you come across a problem that is not equal to 0 as it relates to the quadratic equation, you have to make it equal 0. I don't make the news, I just report it. All right. So last but not least, what is 1 minus 11?
10.
Well, -10, but I'll take it. All right. And -10 divided by 4 can be simplified as a fraction to -5/2. Oh, that's so ugly. Y'all do not deserve that. I ain't even gonna do y'all like that. All right. So again, Miss Hampton, what does all of this mean? That means my two answers are what's circled. 3 and -5/2. Those are my answers. And that means I can put it back into the original equation, which would be this up here. And my answer should be 2. It should be.
The 5/2 is fraction, right? So you don't
What
have
was
to do
that?
nothing.
What was your question, Mr. McFadden?
I said the 5/2 is an improper fraction, so you don't have to do anything with that.
You don't necessarily have to, but again, if you want to check your answer to make sure that that is your answer, I will convert the -5/2 to a decimal because decimals are easier to multiply versus fractions. So if you feeling fancy and you want to say -2.5, okay, it's cool. Okay. So in essence, what you would do is you would simply just substitute these answers back into the original equation to make sure that they check out. Okay, that's what you would do. Now, with the exception of Robert, I've emailed you all a worksheet already. I want you to practice doing maybe a couple of problems using the quadratic formula. Robert, I'll be sure to email you the worksheet so that way you can have it. Okay. If you're
Okay.
still okay, I just wanted to make sure if you're still on. All right, because it is 12:02 and I have to process this video and put it up so that way everybody can see what's happening and what's going on and all that good jazz. So I'm going to stop the screen share right now. Do y'all have any questions for little old me?
No, ma'am.
No, man.
All right. Okay. So just remember, Robert. I'm going to be sure to email you that worksheet right now. As for everybody else, you all should have that worksheet. And I want you just to do a couple of problems just to familiarize yourself with the quadratic formula and to get comfortable with the quadratic formula. Okay.
Okay.
So I have some news.
You have some news. Okay, I'm still recording, Miss Tiffany.
Oh, well, I'll
So
wait
is
till
it
you get done with that.
okay, wonderful. Because I don't know what kind of news it is, and we definitely don't want to, so I don't know. All right, so let me go ahead and end this video. But remember, please make sure that if you have any questions, please feel free to reach out to me. Anybody that's watching this playback video, leave it in the comment section, and I leave your questions, concerns, whatever in the comment section, and I'll be sure to answer those momentarily. So let me go ahead and get Robert situated with his worksheet so that way he can have it, and I can get ready for what I got to get ready for. All right. So I love you all. There's nothing you can do about it. And I see y'all on tomorrow. Bye.